All right, let's do a little bit. I call this special product formulas. Well, I don't call it that. The book calls it that. It's really not much different than what we've done before. There's a couple things might be a little different, but it's really, I know exactly what they're doing. They're trying to prepare you for not the next lesson, but the one after that. And I'm going to show you, I'm going to give you some hints and stuff like that. But I'm not going to really have us use these formulas. I'm just going to have us just straight multiply the way that they want. None of that probably makes any sense to you, but I am going to show you. So the first formula, all right, I will introduce these formulas, but we're going to use them a little bit later. I'll just leave it at that. So here's the first one. If you had something that looks like this, right? And if you needed to multiply this together, tell you what, let's just do that. Let's multiply this. I don't have any numbers in there, but that's all right. It's algebra. We can multiply letters, can't we? Well, we can add letters together and stuff, so let's go ahead and do that. So this is FOIL method, right? What we talked about yesterday. So it's FOIL method, so let's go first, outside, inside, last. So the first is what? X squared. The outside, x times a. You could put xa. I like ax better. The inside is negative a times x, so it's minus ax. And then the last would be negative a times positive a, which is negative what? A squared. A times a is a squared, isn't it? Yeah? Are we finished with this? No, not quite. We can still add some like terms, so let's add those together. And that's actually kind of easy. What's positive ax minus ax? Is 0. That's right. It's just a 0. They kind of cancel each other out, don't they? They just add up to 0. And what else do I put down? Minus a squared. So this is the first formula, and let me give you the name of the formula. So once we get this answer right here, the name of the formula will make some sense. Okay? So we call this the difference. Everybody should be writing this down. The difference of two squares. That's the first time you've heard that in here. You may have heard that before. Did you ever hear that in your Algebra 2 class? You ever do that? Maybe even in your Algebra 1 class, they talked about this. This is probably something that they discussed in Algebra 1. But if not, now you heard it, okay? Why do you think they call it the difference of two squares? Is that just some random name that they made up? No. What's the word difference mean? You subtract. Do you see any subtraction here? Absolutely, right there. So that's a difference. Of what? Of two squares. Look at this. That thing's being squared, and that thing's being squared. There's two things that are being squared. Agreed? All right, so do you understand why they call it the difference of two squares? Absolutely, all right? So this is a difference of two squares. So if I had something like this, to tell you the truth, I would just do the FOIL method. But they're saying, here's a formula. You could just remember that if you have like this, watch, x minus 3 times x plus 3. You're like, oh, that looks familiar. That looks like one of those difference of two square things, right? So how would I write this? Look what you did. You just took the x's and you squared it. So in this case, you take the x's and you square it. Then you put a what? A minus, and then you take the other thing, the number, which is the a in this situation, the 3's, and you just square that. What's 3 squared? 9. So you could go directly from there to there. I don't know if that's a good idea when you're multiplying. I would just do the steps. So if it was me, and when I say if it was me, that means if it's you as well, all right? So this is the way I would do it if I were you. All right, and this is the way you should do it. I would do the FOIL method. X times x is x squared. The outside is plus 3x. The inside is minus 3x. And the last is what? Negative 9. What happens here? 3x minus 3x is 0. Look what I'm left with. X squared minus 9. I think that's a good way to do it instead of trying to memorize all these formulas, okay? I think it's too complicated. Now, I said that for multiplication. In a couple lessons from now, they're actually going to do this. They're going to start with this thing. They're going to give you x squared minus a squared, or x squared minus 9. Get my marker to work here. And they want you to come up with what's being multiplied to give you this. Okay, and that's called factoring. You guys ever remember factoring? Yeah, that's definitely an Algebra 2 topic. It's an Algebra 1 topic as well, but you really hit it hard in Algebra 2. Okay, and we're going to talk about it in here. We're not doing that right now, but we will do that in a little bit. So I think it is important to understand that phrase, the difference of two squares. Look at that. Is that a difference of two squares? Yeah, because I see a difference. I see a minus. And I see something's being squared here and something's being squared here. Agreed? Look at this. Is this a difference of two squares? Well, there's my difference, the minus, right? And is something being squared here? Yeah, the x is. Is something being squared to give you 9? A 3 is being squared, isn't it? So something is being squared to give you 9. So is this a difference of two squares? Yes, it is. All right, so when I said before, we don't really have to memorize these formulas to get the answer. That's true, I'm sticking by that. But in a couple lessons from now, we're going to start with this, right? We're going to start with that, and we want to end up with this whole thing right there. All right, we're just going backwards. I call it the backwards FOIL method, okay? It's kind of what it is, backwards of the distributive property. So we're going from the answer to the question. We're going to do that again in a couple lessons. Just thought I'd throw that out there so you could see it. Because a lot of the stuff we're doing right now is the same kind of thing. Here's another one that they give you. And again, right now, I don't really think it's that helpful to know it. But later on, we will use it. So what if I had this? X plus a squared. Before I tell you what that's equal to, let's work it out and figure out what it is. So if I had something like this, I would work it out. I wouldn't try to memorize this formula. I think it's harder to memorize the formula than it is to actually do the work and come up with the formula, to tell you the truth. I just don't think it's a good idea to have these things memorized. Let's just do the work. Well, we talked about this yesterday, I believe, didn't we? What does it mean to square something? We multiply it what? By itself. So that's what I'm going to do here. I'm going to go x plus a and then another x plus a. Is this a difference of two squares? No, because difference of two squares, one was plus, one was minus. All right, so it's not a difference of two squares. Everybody understand that first part right there? That's super important, because you know what a lot of students, I almost hesitate to even say this so that you don't make this mistake, but I'll say it anyway. A lot of students do this. They go x squared, what do you think? Plus a squared. That's not correct. That would be using like the distributive property. This is not distributive property. You do not have distributive property with exponents. Everybody understand that? All right. Like if I had a 2 outside of x plus a, then yes, I would distribute it. I would go 2 times x plus 2 times a. But there is no distributive property when you have exponents. Let that sink in. Okay? So when I square something, I got to multiply it by itself. Now, I can just do what? What method can I use now? The FOIL method. Okay? So let's do that. So first, what is it? X squared, correct? Outside, these two right here, what's that? You could say XA, but how do I like to write it? AX. And let's do the inside, these two. That's already written as AX. And let's do the last, these two right here. A times A is A squared. Are we done? Do we circle that? No. We try to add like terms. Are there any other x squareds? Nope. What about this? Yeah, those are like terms. I got one AX plus another AX. How many do I have? I got 2 AX. Plus, what's left? A squared. And that is this. Okay? Let's do another one. We'll do some regular numbers here in a minute, but let's do this. What if you had this? What do I do with this? It's basically the same idea. I'm squaring this stuff in the parentheses, correct? So what do I have to do? Do I go x squared minus a squared? No. I go x minus a times what? X minus a. Good. And now we do a little FOIL method with this. We did it over here. We'll do it a little quicker this time. X times x, x squared. Now look at this. It's x times a negative a, which is what? Negative ax. Everybody see that? It's a little different. Then we do the inside. Negative a times x is negative ax again. Now watch this part. This is the part where a lot of people mess up. So watch, write it down, and hopefully you won't get it wrong. I got negative a times negative a. What's negative times a negative? It's positive, so we put a plus here, okay? And then a times a is a squared. Everybody see that? It's a little more complicated than this. This, you didn't have to worry about your signs at all, did you? Everything was positive. Everybody's happy. Right here, they throw in negatives. It messes things up a little bit for us. Landon, you getting all this? It'd be nice if I saw your eyes. So now what we have to do is add the like terms. So what do we have? I got x squared. How do I add that? It's negative 1 of these minus 1 of these. What is negative 1 minus 1? It's negative what? Negative 2. So what do I have here? Negative 2 what? ax. All right? And then what's left over? Plus a squared. You do. Well, yeah, I guess if you put it in descending order, you would think that A would go first, right? Or the
staff in the upper school have not gotten their pictures taken. You can go down to the Fuji lobby now. Also, with the following students, please come to the office. Sarah Jones, Scarlett Taylor, Gabby Calvizano, Angela Main, Abby Sawas, Layani Zavala, Terrell Pryor, and Akira Linton Patrick. Thank you.
All right, here we go. I know she has to make those announcements, but still irritating. All right, here we go. What was I going to say with this? Oh, the descending order thing. Good question. I never even thought of that, actually. But you're right. You'd think you'd put the a squared and the x squareds at the beginning, wouldn't you, for descending order? But for these, we just leave it like this, okay? So that's what we do here. The reason is because these a's are actually going to be like actual numbers, you know, and so you'd put that at the end anyway. So that's probably why they do it like that, all right? Now, what they're trying to do in the book, they are saying you should recognize that, well, you should recognize this and just by memory of a formula, be able to say it's that. Do you think that's an easy thing to memorize? I don't think so either. Don't you think it's just as good or better to just multiply it out and come up with it? Absolutely, okay? But on the other hand, remember what I said on the other ones. Eventually, in the next couple lessons, we are actually going to take something like this and look at it and recognize that it's that right there, okay? We call these, yeah, they call it squares of binomials, but I'm going to call it a perfect square. And we are going to talk about this later on. It's a perfect square, which means whatever's inside that parentheses being squared, we call that a perfect square, okay? So you could have x minus 3, all right? That would be considered a perfect square. Again, there is a reason to know this, but for right now, if they just give you x minus 3 squared, I would not try to memorize this and put all those numbers into that. I think that's way too complicated. What I would do is just do the multiplication. So let's do one. We won't do the plus one because that's kind of easy, all right? We'll do the minus one because that could trick us up a little bit. So how do I write this? Well, we've already done one of these, haven't we? Maybe not. Or did we? No, this is different. All right, so x minus 3 squared is what? X minus 3 times what? X minus 3. Yeah, we did do something like this. Let's just do it quick now. So that's going to be x squared. What's the outside? Negative 3x. What's the inside? Negative 3x. What's the last? Negative 3 times negative 3 plus 9, correct? What happens here? X squared. What's here? This doesn't add up to 0, does it? Like on the other one we did with the difference of two squares. You're right. It's going to be a minus 6x and then plus 9. Everybody see that? I want you to see something though. This is just kind of a heads up for what we're going to teach again in a couple lessons from now. I want to see, this should kind of pop out to us a little bit, all right? I see something that's being squared here, right? I see something that's being squared here, right? What's being squared to give you 9? 3. But look at this. Do you see how it says negative 2ax? What was the a? It would have been a 3, right? Look at this. This is 2 times 3. You watching? All right. So this 6, it doesn't just happen to be 2 times 3, right? It's 2 times 3 for a reason, because of this. I've got a negative 3 here and a negative 3 here. There's 2 of them, right? So that's why the 2 right there. All right. So if I see this, I should recognize, oh, I got something that's being squared here, something's being squared here, and what's being squared here? A 3. If I take that 3 multiplied by 2, I get that number right there, don't I? All right, so I look at that and I'm like, oh, it fits the pattern. What's the pattern? This is a perfect square pattern. So that means I can turn this into this. We'll deal with that. It's just a sneak preview. Like I said, I'm not really trying to teach you that, but that's what we're going to learn in a couple lessons from now. Everybody good? All right, so don't worry about that. I'm getting all excited about going a little extra. I don't need to go that extra, so we'll just stop right there. Let's do, when's this at over? Quarter after? All right, so I got lots of time. So I got time to do some examples. This is example 8, and they give you quite a few of them. They give you 4 of them to do. I'll tell you what, the A and the B, we've basically already covered. Not that big of a deal, so I'm not going to do that. Let's do example C, part C to example 8. All right? It's basically the same thing, but with just a little bit of a twist. All right, they tell you to simplify or multiply. I think that's pretty much what they're going to say. I didn't write it in my notes what they actually tell you to do, but they want you to come up with an answer for this. All right, simplify it, multiply it out. So this thing is being squared. It's a perfect square, isn't it? So what am I going to do? I'm going to multiply it by itself, correct? So I take everything inside of there and I just multiply it by itself. Put 2 of them there. Now I can do a FOIL method with this. Does that make sense? Yeah, it's just, what's the only thing different on this compared to what we've done so far today? Yeah, you got that 2 in front of the x, right? We didn't have that before. We just had an x, didn't we? All right, but now we got that 2 in front of there, which doesn't really, I mean, it adds just a little bit of extra work, but not too much. So now, let's do the FOIL method. Let's do the first. If I multiply 2x times 1, what do I get? 2x times 1. It's just 2x. Okay? And then, that was the first. Let's do the outside. Oh, I'm sorry. I went to here, didn't I? My bad. My arrows should have been to there. That's probably why you were mixed up. My fault. So that's the first. 2x times 2x. I'm messing everything up. Hold on. Let's try this one more time. Let's start over. Rewind. All right. That was my fault because I went from here to here. All right, let's do the first. 2x times 2x. What is 2x times 2x? 4x squared. Very good, because 2 times 2 is 4. X times x is x squared. Now, let's do the outside. What's the outside? 2x times 1, which is 2x. Good. I'm glad you gave me those looks because that made me stop. If you see me mess up and you know I messed up, let me know. I don't mind. Okay, I won't yell at you. I'll be very happy. All right, so what about the inside? That's also going to be a 2x. Everything's plus, so we put plus here. And then the last is going to be what? Plus 1. Remember, they're being multiplied. 1 times 1 is 1. Can you simplify this? Sure, I can add like terms here. So I've got 4x squared plus 2x is 4x plus 1. And that's what I would do right there. This is a perfect square. Hold on, let me see something. It is a perfect square. It's just a little bit different than what we did before. Yeah, that's good. Let's do another one. Let's do one more of these and we'll do something a little bit different. Take it a step beyond. So this time, we're going to make it a little bit tougher. Put a minus in there. Just putting a minus in there makes it just a little bit tougher because sometimes we get the signs mixed up. And instead of this being a 1, I'll make it a 4. That makes it a little bit tougher as well. But what do we do right at the beginning? What do we do to start off with this? We write it 3x minus 4 times what? 3x minus 4. Make sure that you do that. Again, don't fall in the trap where you think you just square everything inside the parentheses. That is not what we do, right? Not when you have a minus or a plus inside of there. If everything was just being multiplied in the parentheses, then sure, we could take everything to the second power. But when you got a minus or a plus, you can't do that. You got to write it like this. You getting the hang of this thing now? We've done a lot of FOIL method today and yesterday. So let's do some FOIL method. Let's do the first. What's that going to give you? 9x squared. Let's do the outside. Okay, the two outsides. 3 times 4 is 12, but you got a negative though, don't you? So what's this going to be? Minus 12 what? X. What's the inside going to be? Negative 4 times 3 is negative 12 again, and x. Anytime you have one of these perfect squares, these two are always going to be the same thing. And then let's do the last. Negative 4 times negative 4 is positive 16. The signs make a difference, okay? So make sure you put the plus there. All right, so I got 9x squared. What do I have here? Negative 12 minus 12 is negative 24, okay? Or do you remember what that formula was? It's 2ax. Do you remember that? So look at this. Hold on, let me think about this. Yeah, that's good. 24 and then x. And then what do we have next? Plus 16. And that's it. That's how we multiply those together. Pretty easy, isn't it? Yeah. We're going to do another multiplication, but they're not going to be two binomials, so we can't do FOIL method, but it's going to be really, really close. We're going to take one binomial and multiply it by a, what do you think? Well, we already did one binomial times another binomial. We're going to, a trinomial, that's right. All right, so let's do this. But before we do that, I'm going to show you this. This is example 9. We are going to take, we'll start off pretty easy, x plus 2. And instead of squaring it, what we're going to do is cube it. All right, take it to the third power. Now, when it was to the second power, what do? We put two x plus 2's next to each other, right? What do we do when we cube it? We're going to put 3 of them next to each other. So let's do that. So I'm going to go x plus 2 times another x plus 2 times another x plus 2. Does that make sense? Because you're cubing it. When you cube something, you multiply it times itself 3 times instead of just twice. Okay, so we got 3 of them here. Now what we're going to do is this. Everybody watch. We're not going to do them all at once. Okay, what I'm going to do is I'm going to break them down into a FOIL method. So watch. I'm going to take this and figure out the answer of that. Once I get the answer to this, then I'm going to multiply it by this outside x plus 2. You follow me on that? Because for instance, if I had something like this, if I had 2 times 3 times 4, does it matter what order you multiply these two things in, or these three things in? Everybody looking up here? Look, 2 times 3 times 4. I could go 2 times 3 is 6 times 4 is 24, couldn't I? Or I could do what? 3 times 4 is 12 times 2 is 24, yeah? Or I could go 2 times 4 is 8, which is, 2 times 4 is 8 times 3, which is also 24. Doesn't matter. I just think it's easier to multiply these last two together, and then I'll multiply it by this x plus 2. So I'm going to still put that x plus 2 right there, but I'm not going to really mess with it right now. What I'm going to do is figure out what this is equal to. Everybody good? So let's do it. This is just FOIL again, isn't it? So x times x, should be good at this now. Plus, can we do this in our head, that outside inside? Yeah, let's do that. What's the outside? 2x. What's the inside? 2x. Add them up, you get 4x. And then plus what? 4. You okay if we do that? Yeah. If you're not, write down this step if you need to. It's perfectly fine. But I think after you do these for a while, there's some things you can kind of knock out, and that's what it would be. Now, remember what I said earlier before we started this example? We're going to take a binomial and multiply it by a trinomial, and that's what we have right here, isn't it? So we don't really have FOIL method, but we're still doing distributive property. All right? I'm still taking that x and multiplying it by what? Everything in the other parentheses. Then once I'm done that, then I take the what? Not the bottom, there's no bottoms. The 2, right. And then I multiply it by everything. Do you see that? And we've done that before. If you look in your notes, we've actually multiplied a binomial times a trinomial before. Okay, when we first started this section. So let's do it. All right, so let's do the first. Okay, the x times the x squared. Go ahead and say it. You said it already. X cubed. All right, and then x times 4x, what's that going to give you? Plus 4x, what? Squared, right, because it's x times x. Now we're going to take the x and multiply it by the 4 plus 4x. Good. We're only halfway done, though, aren't we? So now we got to take the 2 and multiply it by everything in the parentheses. So let's go 2 times x squared. What's that going to give you? 2x squared. Very good. Plus, take that 2 times the 4x. 2 times 4x is 8x. And then, one more. 2 times 4 is just 8. I said earlier we were halfway done. Actually, we were a little less than halfway done because we got to add some like terms here. Now, here's a situation where you do want to put it in descending order. Okay. So what's the highest exponent that we have here? X cubed. So let's write x cubed first. There's no other x cubes I can add it to, so I'm done with that. What's the next highest power? X squared. So let's add all the things with x squared. Well, that's got an x squared, and that has an x squared. Let's add them together. Plus 4 plus 2 gives me plus 6 x squared. I'm done with those two. I got a couple more, don't I? I got this and this. Add those up. 4x plus 8x is plus 12x. I'm done with those. Last thing, plus 8. Is everything added up? Are all my like terms added up? Yep. Is it in descending order? Yep. Now I can circle it, and that's my answer. Again, we've done that before. We haven't done this part before, though. We didn't do the thing where we did the cubes, all right? So I multiplied these two first, got an answer right here, and then I multiplied it by this one on the outside, and then I got my final answer. A lot of room to make mistakes there, isn't there? All right, with that multiplication, with the signs, imagine if that was a negative, all right? You'd have to make sure you get your signs right and make sure you add your like terms correctly, all right? So there's a lot of things you have to do right to get that. And since I mentioned the minus, let's do one with minus. Yeah. Let's see, I'll just use the one in the book. X minus 1 cubed. All right, let's do this one. You know the first thing to do, right? Write it all out 3 times. Good. X minus 1, X minus 1, another X minus 1. So again, what I like to do, I like to take these two, but it doesn't matter. They're all the same anyway, right? But take any of the two, but I like these because I like to stick that X minus 1 out front. That's why I do it like this. And let's do the math. So now this is just FOIL method doing these. So x times x is x squared. Can we do the next part in our head? What's x times negative 1? Negative 1x, negative x. Minus another x. What's negative 1x minus 1x? Tell you what, let's show this step, okay? The negatives can be confusing, so let's show the step. So the first is is x squared. The outside is negative 1x. The inside is negative 1x. And the last is positive 1. We still have to add those up, don't we? Now, if you could do that in your head, it's fine. Just, put it in that step. But if not, go ahead and write it all out. So I've got x squared. What's negative x minus x? Negative 2x, right? This is the same as negative 1 minus 1. Negative 1 minus 1 is, add a line, change the sign, is negative 2. Negative 2x, and then plus 1. And now we have to do the distributive thing. I'm not going to draw all those lines here. All right, let's just do it. So if you do the first two, right, x times x squared, that's x cubed. Then you go x times negative 2x, that's going to be a minus 2 what? X squared. And then you go x times positive 1, which is positive x. So I multiplied everything in here by an x, didn't I? Now I have to multiply everything by a negative 1. So it's negative 1 times x squared, which is negative x squared. Negative 1 times negative 2. What's a negative times a negative? It's positive what? 2x. And then negative 1 times positive 1 is negative 1. I know I'm going kind of quick here, but you can always watch the video, rewind it, slow it down a little bit. Is that my answer? Do I circle it? No, I always have to find like terms. So what's my highest power here? X cubed, and I'm done with that. My next one is x squared, so I'm going to add this to this. This is where a lot of students make mistakes, so watch carefully. This is a negative 2. Everybody see that? It's not just a 2, it's a negative 2, and this is a what? A negative 1. What's negative 2 minus 1? It's negative 3 what? X squared. Okay, it's really important. That's a part right there that a lot of kids mess up. So I'm done with those two. Let's do the x's. This is a positive 1x plus 2x. That's easy. That's 3x. Done with those. Last thing, minus 1, and there you go. If you notice, nope. I thought the other one was x plus 1, but it was x plus something else, what, 2. Yeah. So, yeah, there you go. I think that's it. All they do is, again, they're trying to get you to see these formulas and trying to get you to memorize the formulas. But like I said earlier, I think it's way easier just to work the thing out, okay, instead of trying to memorize a formula, then plug it into a formula. There's sometimes formulas are great. In this situation, not so great. But I think I know what they're doing, though. They're trying to prepare you for that factoring that I keep referring to, right, over and over again. I keep saying, in a couple lessons, we're going to do this factoring thing. And they keep referring back to that, which I can understand. I get it. But I'll just teach you how to factor when we get to it, instead of memorizing all those kind of things. All right. So we got like 7 minutes left. So I will look at your homework. And here is your new homework. Your homework from yesterday I'll look at. So here's your new one. So it's R-4C. It's page 48. and it's 65 to 87. And again, it's just the odds. Okay? All right, I'll stop recording, but I want to go over some questions you might have had. To tell you the truth, with all the FOIL stuff we did today, that probably answered most of your questions from the homework, wasn't it? Was it just all FOIL method from your homework? Yeah, so it shouldn't have been that hard, should it? Okay.